In this video, we'll use Unity's economy service to create currencies and inventory items for players. Both can be earned and used in-game, and they can be purchased with virtual and real currencies. After setup, we'll work in Cloud Code again to get the initial gold that the player starts out with. From there, we'll initialize the player with some starting inventory items, and then we have enough in place to build out a system which handles both new and returning players at the start of the game session. For a full example of implementing an in-game economy, check out the Gem Hunter Unity Gaming Services sample project at the link below. We'll continue working with our learning project building out economy functionality from scratch. Start by going to the Unity Cloud dashboard and the page of your project. We have another service to add in the shortcuts plus, this time add economy. Go up to configuration and then click on add resource. Let's start with a currency, and I'm going to do generic gold. After we type in the name of our currency, an ID is created for us. Let's have the player start with 100 gold and set the max as 100,000 gold. Click Create on the bottom right, and we're done setting up gold. Let's do another, click Add Resource again. Now let's do an item, and I'll do a health potion. You can do whatever you like. And there's our ID. Let's click Inventory Item. Click Add Custom JSON, and then in curly braces, add the property amount in quotes. Put a colon after amount and a 0 for the value. Click Create, and there we can see the custom data. The configuration we've set up is not yet live. We need to publish it, so click on Publish at the top right and publish. Back in Unity, let's install the economy package. Open up the package manager and use the little cloud icon for the Unity services packages. Find economy and install the economy package, and you can grab the samples too. Open up the folder with your scripts and open the player data manager. Previously, in our other login manager script, we created a sign-in event that is invoked on successful sign-in. That is, it's invoked right after a successful anonymous sign-in for both guest play and returning players. We also want to invoke this event after each platform sign-in method. So invoking the player sign-in event after any sign-in the player uses, like after Facebook sign-in. Player data manager's initialize player method subscribes to this event and calls the example say hello Cloud Code function we started with. Before we jump into Cloud Code, I wanted to establish the context on the client side here. Instead of this say hello, we want to instead initialize the player's data, like their starting or saved inventory and currency. Let's do this one step at a time. Open your Cloud Code solution, and let's create a new class that is dedicated to the player's economy. Right-click on the project name in the Solution Explorer and create a new class. Call it Player Economy Service. Let's start with a getCurrencyAmount method. To get the player's currencies, we use GameAPIClient.economycurrencies.getPlayerCurrencies.async. Therefore, the getCurrencyAmount method will need to take in the execution context, the Game API client to call the economy service, and let's also have it take in a key. This will be the key that was created from our economy currency's name in the dashboard. We then search the currencies for the first one that matches our key. If you're new to client-server architectures, request or response is a standard pattern for making the flow of data obvious. Request represents the data being sent from the client to the server, and response is for the data being retrieved. Here we're working with the currency balance response, which contains the data returned from the server about the player's currency. We use LINQ, Language Integrated Query, to quickly search through the currencies in the response for the one that matches our key. First or default returns the first matching element or returns the default value for the type if no matching element is found, and that'll be null for reference types like currency balance response. Just first, so without default, returns the first matching element, but throws a generic invalid operation exception if no matching element is found. We're using first or default because it lets us check for null and provide our own contextual error message like we have here. If the currency response is not null, then assuming your currencies won't be going into the billions, cast the balance from a long to an int and return it. The economy service uses the long type to support extremely large currency values, but ints can still hold values to around 2 billion, which is more than enough for most game economies. Finally, in the catch block, we're handling any API exception that might occur when calling the economy service by doing what's called exception wrapping. We provide context about what failed and what specific values were used while preserving the original error message so we don't lose any details. This way we have the best of both worlds, API exception for any Unity Cloud API network problems or authentication issues, and that's wrapped with our own descriptive general exception for context about which currency and player were involved. At the top, let's declare some variables, constant keys for the gold currency, and while we're here, let's also do the health potion item key and a constant int for some starting amount of health potions. Next, let's create a convenience method for getting gold that's a Cloud Code function. This method will call getCurrencyAmount with the gold currency key and return the int of gold the player has. Let's also define a constructor that takes a logger, even though we're not using it just yet. The iLogger type comes from the .NET libraries, but it's Unity's Cloud Code that actually injects it for us via constructor injection when the class is created. Just like how Cloud Code uses method injection to pass iExecution context and iGame API client into our functions. Unlike the logger, context is tied to individual requests, so we'll keep it as a method parameter instead of storing it as a field. Since Game API Client is registered as a singleton in our dependency injection setup, you can store it as a field in the constructor and reuse it across all methods. I've just kept it as a method parameter for clarity that the methods require it. In the case of iLogger, Unity gives us a way to review and query logs directly in the Cloud Code dashboard, which is especially useful for debugging and monitoring in production. Since we added a new class, before we go back to Unity, go up to Build and click on Build Solution. We need to build the solution, our Cloud Code module, because when we click to generate bindings, Unity examines the compiled output, the DLL dynamic link library file, to figure out which Cloud Code functions, the endpoints, we've written in our C# service classes. And all right, while I was yapping, the build completed without error. So let's go back into Unity. And this time, another way we can generate bindings is by selecting the Cloud Code reference file and clicking Generate Bindings in the inspector. As we saw in the last video, these bindings act like a bridge, so we can call our Cloud Code functions directly. We can check out the bridge by going to Cloud Code, Generated Module Bindings, your Cloud Code project name, and there you'll see bindings generated for each Cloud Code class. I'll double-click on our new one, Player Economy Service Bindings, and there we have Get Player Gold. Let's test it. Go back to the Player Data Manager. Our Player Data Service Bindings won't have Get Player Gold, so we need an instance of Player Economy Service Bindings. Let's create that in Start. We'll move it to an Economy Manager in a moment. And then let's call Get Player Gold and log the gold amount after our Hello Player name. Before we test, we need to deploy the module so that our economy service is actually on the server. Let's press play and test it. And all right, you might need to log in anonymously first, but our Get Player Gold is working with the initial amount. Go back into your Cloud Code solution and let's implement getting and creating inventory items. Create a new method called getInventoryItemAmount, and here we'll use economy inventory getPlayerInventoryAsync. This method provides filtering where we can just look for the configuration ID for the item, though we still need to retrieve the item from the list. If not null, we'll try parsing the inventory item for the custom data amount. Unlike currencies, which can have a starting amount, we'll need to add the starting inventory items to the player's inventory. We'll do that next, but let's first complete try parse inventory item amount and then set up a convenience method for getting the amount of health potions, just like we did for getting the gold currency amount. Try parse inventory item amount takes in the item response and starts by checking if instance data is null. We then convert instance data to a readable JSON string, which here we're doing with interpolation. Then we deserialize the string into a dictionary, which gives us a key value structure we can work with in C#. We check the dictionary for a key called amount, and then we try to parse the corresponding value into an integer. If that succeeds, we return true with the parsed value. If it fails at any step, we log a warning message and return false with a default value of 0. So here we're handling errors gracefully instead of throwing exceptions. Next, let's create a convenience method for getting the amount of health potions with the health potion key. If we tried to call getHealthPotionAmount now, we'd get an exception because the player doesn't have any items yet. Let's fix that by initializing a new player with some starting items. We'll begin with a generic method called addNewInventoryItem. Inside, we use addInventoryItemAsync. When we call this method, we send an addInventory request that includes the item ID and any custom instance data we want the item to have. Since we want this method to support custom data for any item, it takes a dictionary of string to object as the instance data parameter. This could include things like the item's condition, rarity, the gold value, or any other properties. It's good to have a flexible method for any item, but in many cases, like with our health potions, we're just tracking the number of items the player has. And in those cases, we're using the custom data for the amount. To make that common use case more convenient, we'll add an overload of addNewInventoryItem that takes an int amount. Internally, it just builds the instance data dictionary for us. Now let's create an initializeInventory method, and this will be a cloud code function that for now the client can call when a new player joins the game. It defines a dictionary of starting items, just item ID and amount, and calls addNewInventoryItem for each item. And for now there's just one. Let's assume the starter items only need an amount for their custom data, so we'll just use the simplified overload we just wrote. Back in the client side in Unity, generate bindings. And in the player data manager, after the getPlayerGold, let's do await economy service bindings.initializeInventory. And then from there, let's try out our getHealthPotionAmount and print a log of how many health potions we have. Before we test this, remember that we do need to deploy the module. But after that, press play, and there we go. The player has gold and health potions. All right, now that you're getting the hang of things, let's take the next step in our architecture. We need to implement a way to distinguish between new and returning players. A standard approach is to check for existing player data in CloudSave. If there's no data, we know it's their first sign-in and can initialize the stats, progress, and inventory. Go into your Cloud Code solution, open the Solution Explorer, and create a class called PlayerData. Inside, let's create two data models. The first model is for player data like display name and progress. And for that, let's just do experience. And then let's create another model for economy data, the currencies and inventory. For now, we'll keep the inventory simple, a dictionary with a string key and an int for amount. We also need to include JSON properties because they provide a mapping between our C# property names and the JSON field names during serialization and deserialization. This ensures our data gets correctly converted when sending it between the client and server. Our context right now is initialization of the player session, and the Cloud Code function that handles the start of the game we'll call handlePlayerSignin. From that method, it would be best to return both the player data and the economy data because that gives the client side everything it needs in a single server call. To do that, let's package these two models together in what we call a data transfer object, or DTO, a common pattern in client-server architectures. We'll name this class PlayerDataResponse, since it represents data coming back from our server. And inside, we'll include both the player data and economy data, and we can also include a Boolean flag indicating whether this is a new player. If this DTO is specifically for initial sign-in, and we have some special data for that, like new firm requests or messages from the player's clan leader, we'd want to be more specific in the name and call it player sign-in response. For now, let's keep it generic as player data response, since we can use the same structure for other operations like refreshing player data during gameplay. Let's open up the player data service class. In the previous video, we used this class to validate and save a new name for the player. Now we're going to handle sign-in and manage initial data and economy setup. And that's quite a bit to cover, but the good news is that these are the exact steps you'll need for most projects, so hopefully the next few minutes will save you a ton of time, especially if you're new to this. At the top, let's define a constant key for storing player data. We'll also need to call the player economy service, so inject a dependency on player economy service through the constructor. To make this work, head over to the module config and register player economy service as a singleton, just like we did with Game API Client. Back in the player data service, let's create a Cloud Code function called handlePlayerSignin that takes in the context and Game API Client parameters. First, we want to determine if this is a new or returning player, so we'll try to retrieve player data. If there's no player data found, we have a new player and should call initialize new player. We want initialize new player to handle everything and return both economy and starting player data in the player data response. We'll examine this method soon, but let's continue with our sign-in flow. For a returning player, we already have the player data, so we'll retrieve the economy data by calling a method we need to implement, getPlayerEconomyData, in our economy service class. Finally, we can return the response with player data, economy data, and set isNewPlayer to false for returning players. All right, we have a few methods to write now. Our to-do list is try getPlayerData, initialize new player, and getPlayerEconomyData. Let's implement try getPlayerData. This method will return player data, and we want it to be nullable so we can identify a new player because a new player wouldn't have any player data saved yet. Previously, we copied a getData method from the documentation. However, that method throws an exception if there's no data saved at the key. It's best practice to only throw exceptions for unexpected or severe errors. We shouldn't use exceptions for normal control flow. Missing player data on first sign-in is completely expected behavior, not an error. That's why using the try pattern is perfect here. Ordinarily, try methods return a Boolean and use an out parameter. However, we can't use out parameters with asynchronous methods like our task here, so instead we'll use a tuple, which is a concise and clear way to return multiple values. We'll return a bool called playerExists and the player data object itself. The intention of the method then is really clear. We want to try to get the player data, and if the data is missing, handle player sign-in will handle it and create a new player. To summarize then, we use try methods for operations that might fail in expected, normal ways. The getData method we copied over throws an exception if there's no data saved at the key because it attempts to get the first item from an empty results collection, using the link extension method first. We could easily fix that by using first or default, which returns null for empty collections, or we could add a check like if response data results count equals 0, return null. But instead of getData, let's make the intention clear and instead create a new method, tryGetData, using the same try pattern that returns a tuple of a Boolean and a string value. Now with tryGetData, when we want to get some saved data, we're encouraging ourselves to think about how to handle both cases, when the data doesn't exist and when it does, and make our handling explicit for each case. The reason tryGetData returns a string is so we can handle the JSON serialization separately in tryGetPlayerData. Let's go back to tryGetPlayerData. Here we'll deserialize player data JSON as player data. That is, we're converting the JSON text back to a C# object, and then we return the tuple containing whether the player exists and the player data object. This gives us better control over error handling, because if data exists but deserialization fails, we can catch that specific issue and still return false null rather than crashing the entire sign-in process. Next method to write is initialize new player. Initialize new player should return the player data response, which will contain everything the client needs. Let's start by initializing data for a new player. We'll create this here in the method for now, and then declare the economy data variable. In the try block, we can save the new player data under the player data key, and then handle the economy. Remember how we were calling initialize economy before from the client side to start adding health potions to the player's inventory? We really want to have everything together in the player economy data model here, so we'll create a new method called initialize new player economy that returns the player economy data model populated with a new player's currencies and items. That way we can package the new player data and new economy data together and mark the player as a new player in the response. Okay, initialize new player is off our to-do list, but now our to-dos include get player economy data and initialize new player economy. Go into the player economy service and we'll start with implementing get player economy data. We'll likely return player economy data from other more specific cloud functions. We probably won't be calling this by itself. For example, say the player wins a level, we'd call something like handle level win, and that would return updated economy data with maybe some new items. We can make this a Cloud Code function for now, but we might change this later. Let's create a new economy data object and add the player's inventory and currencies to it. We already created a getPlayerGold method, and we can call it here to get the amount of gold the player has. We'll soon remove the Cloud Code function attribute on getPlayerGold because the client shouldn't need to call that. We'll add the gold amount to economy data currencies with a gold key. The item inventory is just a map of the item key to its amount value. We'll need to create a method that processes that for us, getPlayerInventoryItemAmountMap. Kind of verbose, but it's clear what we're getting from this. Finally, we return the economy data. We'll write the getPlayerInventoryItemAmountMap method soon, but let's implement initialize new player economy next. In initialize new player economy, we want to return the player economy data, but first we'll call our existing initialize inventory method. Remove the cloud code function attribute and make that method private since we're going to call handle player sign-in from the client instead. After the inventory is initialized, we call the getPlayerEconomyData method we just wrote because at this point we've created and saved the new inventory items. To recap then, a returning player is just getting the saved economy data, and a new player is initializing economy items first. Before I forget, let's remove the cloud code function attribute both from getPlayerGold and getHealthPotion, those convenient methods, and make them both private. Before implementing the getPlayerInventoryItemAmountMap method, which creates a simple item key to amount dictionary, let's create a method called getPlayerInventory. We previously created a method called getInventoryItemAmount, where we take an item key, retrieve the item, and get its amount custom data. Let's create a more flexible method that can get multiple or all items from the player's inventory. We can pass any number of keys of the items we want, or pass no keys to get all items. This method will return a list of inventory response objects. That makes this method focus simply on retrieving inventory data from the economy service. This will be useful in the getPlayerInventoryItemAmountMap method, which can call getPlayerInventory and focus on processing the list of items to create a simpler representation, a dictionary mapping item IDs to their amounts or quantities. Right now, in this example, we only care about the item type and its amount. The getInventoryItemCustomData method allows us to easily extract any custom data we're looking for. In getInventoryItemCustomData, as described in the summary comment, we're extracting a single field from an inventory item's instance data. This approach is more flexible because it allows us to access any custom property stored with our items without having to create specific methods for each property type. Before we go back into Unity, go back to the Player Data Service class and go to your handle new player name cloud code function because we should save the player's name as the display name inside the player data model. If the player name is valid, try to get the player data, then save the new name to display name, and save that data using the player data key instead of the player name key. And we can just return the new name value here. This lets us change the name in the player data model, and then we'll get that name back when we sign in. Now try building the solution again. Then go back into Unity and regenerate the bindings. You'll likely get an error here because we've changed a few things and some of the cloud code functions are no longer available. In the Player Data Manager, delete the previous code we had because now we just want to call handle player sign-in, which returns the player data response. What we should do with this in the Player Data Manager is save a local copy of the player data from the server. We don't want to save the economy data here because you'll eventually want to create an economy manager class that owns a local version of player economy data. Speaking of creating an economy manager, let's delete the player economy service bindings here because we don't want the player data manager to call economy-related cloud code functions directly. That should be the future economy manager's responsibility. The player data manager should define a player data updated event that takes player data as a parameter. This event can be subscribed to by UI components that need to display the player's experience and name. Whenever we get updated player data from the server, we can invoke this event to notify all interested components. From here, let's log all the response data to verify everything is working correctly. Before pressing play, go to the deployment window and deploy the module. Press play, and if it works for you, great, but if you're like me, you get an error here about duplicate health potions. Go to the Cloud Dashboard to Player Management and check out your player ID. You might have a bunch of duplicate health potions from the way we were initializing the inventory before. I was planning out the tutorial and ended up calling initialize inventory a bunch of times. Let's just delete the players we have, start from scratch. Okay, we don't have any players. In the Unity editor, press play. We'll get a session token exception, but that's fine. We can bring back our buttons and do anonymous sign-in. And there's our player sign-in response log. And we see that we have a starting new player name, we have 0 experience, we have gold, and health potions. In our next video on virtual purchases, we'll start our own pharmaceutical empire because we'll set up a virtual purchase of buying health potions with gold. We'll also cover more important general stuff there, so you won't want to miss it. See you there!